quadratic functions. Like I said, this chapter very, very much, very big part of pre-calc, okay? So your standard form for a quadratic equation, what's called standard form, would be P of x equals ax squared plus bx plus c. You've probably seen that before. Ax squared plus bx plus c. Where that's this c right here is your y-intercept. Your y-intercept. Now, there is another form called a vertex form for a quadratic. Ooh, my dog is going crazy and moving my camera. The vertex form, and I'm going to write y equals a parenthesis x minus h squared plus k. And the h and the k are known as your vertex. Oops, vertex. And you got to switch the sign of h. H, and then k stays that sign, whatever that sign happens to be. So this is known as the vertex form because you can see the vertex, you can read it right there. This one, you would have to do some work to find the vertex, okay? So the first example I have to show you would be complete the square of P of x equals negative x squared minus 6x minus 8 in vertex form and graph. Complete the square of negative x squared minus 6x minus 8. Now, this would be very easy to just plug into a calculator, obviously, and get yourself and be like, oh, I can find it. This is easy. But remember, they're going to ask you questions and they're going to put it in vertex form. So you're going to have to make sure you do it, the completing the square part. Sorry, I'm trying to change pens here because I feel like my one pen you can't see too well. Let me see if I got another one. Here's my black one. Okay. So the first thing I do is, let me write it again. Y equals negative x squared minus 6x minus 8. I like to write it with y's. Okay. So first thing you do is bring the number to the other side. Bring the number to the other side. So you see this number right here? Bring it to the other side. Well, what happens when it goes to the other side is it changes the sign. So this minus 8 now becomes positive 8 plus y equals negative x squared minus 6x. Okay, now you're like, how did that help us? Well, here's what we're going to do, because remember, we're completing the square to figure this out. So what you do is you write this side again and you put plus blank. And then you write this side and you also put plus blank. Now, if there's a negative here, you want to factor that negative out. We're going to make that little notation there. If there's a negative, factor out a negative. And make your blanks. So on this side of the equal sign, I'm going to factor out a negative. X squared plus 6x. Leave this as plus blank for right now. We'll change it in a minute. Even though we're factoring out a negative, leave it positive. All right, now, if you remember, hopefully from your days of high school, how to complete the square, it's very easy. You take half of the middle, and you square it. And that's what goes in the blank. And you add to both sides. So here's what I mean. Half of middle, what do you mean by that? Half of this middle trinomial. What would be a half of the middle term right here, 6x? What would be a half of 6? Well, a half of 6 obviously is 3. But then you want to square it. Well, 3 squared is 9, and that's what goes in that blank. Well, what goes over in this blank, if this wasn't a negative, and this, you just put a 9 here, you put a 9 here. But because we had factored out a negative, we actually have to do -1 times 9 and put -9 here. That only happens if you had to factor out a negative. Now, you're probably like, this looks like a mess. How is this helping us out? Well, we got to clean it up. It'll get clean, I promise you. We're working side to side. So, but the trick is half the middle squared. That's how you complete the square. Now, what does that do for me? Well, this right here, x squared plus 6x plus 9, can be factored. It can be written as x plus 3 squared. X plus 3 times x plus 3 is x squared plus 6x plus 9. It's hint, hint, hint. It's always going to be whatever you took a half of. That's what's always going to go here. That -1, that'll stay out here. So all I'm doing is cleaning up. Clean up, clean up, clean up. That's the right-hand side. The left-hand side, I can combine the 8 and the -9. 8 and -9 make -1. So I'm going to have y minus 1 on this side. So step number 4, you're pretty much simplifying and write in a factored form. You want everything to be with parentheses on the one side, a factored form. Once you get it to this part right here, you just bring that 1 back over, get that y by itself. So I would have y equals -1 times x plus 3 squared, and I'm just going to bring that 1 back over here, plus 1, and that is the vertex form of -x squared minus 6x minus 8. If you were to graph both of these right now, they'd be the same exact equation. Now, how can we graph this? This is what's really neat about it. So my vertex would be the HK, but you have to change the sign of H. So my vertex would be -3, 1. And so you're going to put a little dot at -3, 1. Now, what does that -1 tell us? We know this. And we know this from all the shift stuff too. Remember, if you're positive, if you're inside the parent, you move to the left, then the outside the parent, you go up 1. There's my vertex. What is that negative outside? Well, that means that the U normally makes a smiley face. Well, now it's going to go upside down. So it's going to go like that. There is a y-intercept, back to the original equation, right there at -8. So there's going to be a y-intercept right here at 0, -8. And then one more thing that's kind of neat is this idea of an axis of symmetry. There is an imaginary line that goes down the middle of the parabola, so that if I fold it along that imaginary line, here I'll highlight it for you. If I fold right there along that yellow line, these two halves would land on top of each other. Well, that axis of symmetry we write as an equation. All vertical lines are written as x equals. What does x equal? X equals, it's right there, -3. These are the parts that you would have to find from a quadratic equation. Vertex, you'd have to write it in vertex form. You'd have to find the vertex. You'd have to find the axis of symmetry, which is really from the vertex. The y-intercept is just found from what the original equation was. Okay? So now, complete the square is not fun. It's not, but if you take the time to go through all the steps, bring the number to the other side, change the sign, factor out any negative, take half the middle and square it, write this side in a factored form, combine this left side, it should all work out. We're going to do another one of them. So don't think, oh gosh, that's the only example she'll give me. I'm going to do another one of them in a minute. People are waiting in the lobby. Hold on one second. It always says that people are waiting in the lobby and maybe somebody left. All right. Let me go back to my screen here. All right, so let's do another concept here. So your quadratic function can be written in standard form as p of x equals ax squared plus bx plus c. Or, obviously, in vertex form, p of x equals a times x plus h squared plus k. Okay? Now, there's a formula to find the axis of symmetry. And I'm going to abbreviate it AOS, so I don't have to write axis of symmetry. The formula is really neat. You can find the axis of symmetry, and it's always written as x equals. It's always, always, always written x equals negative b over 2a. Negative b over 2a. So this axis of symmetry, you can find it from the standard form. You put negative b over 2 times a. The vertex, another way to find it, instead of completing the square and all that, is you could take this x value that you got, the axis of symmetry. If you notice from my previous example, didn't the vertex land on the axis of symmetry? So those x's must be the same. So my vertex is negative b over 2a for the x, and then plug that back into the equation, and that would be the vertex. Plug back into the equation. So this is another way to do what we were just doing before. Okay, and I will show you another example. Because again, mathematics, there's just so many ways to do the same thing sometimes. So I want to show you all the different ways, and hopefully you'll feel familiar with it. So here is p of x equals negative 3x squared plus 24x minus 45. And it says find the vertex, axis of symmetry, and graph. And again, I know you can easily put it in your calculator, and you can read a lot of things, but let's find some of these axis of symmetry and vertex from doing the formulas. Okay, so this is your A because it's next to the squared. This is your B, and this is your C. So to find the axis of symmetry, the equation is x equals negative b over 2a. Negative b. So negative b would be negative 24 over 2 times a. 2 times negative 3 is negative 6. Well, negative 4 divided by negative 6 is 4. So my axis of symmetry is x equals 4. That is the line that it's going to go down. So I'm just going to kind of give me a little sketch right here. 1, 2, 3, 4 on the x. And then just make a little dashed line. So I know my parabola, it's either going to smile along this line, it's going to go upside down along this line, somewhere along this line. The vertex, how do I find the vertex? Well, look at what I did up here. You take whatever you got for x, and to find your y, you put that back into the equation. So here's what I mean. This 4 is going to be my x. I need to find that y value. Well, how do I find a y value? You plug it back in. You put it right back in to the equation right there. So P of 4, what would it be? Well, it would be -3 times 4 squared plus 24 times 4 minus 45. And let your calculator do all the work. Let's see what I got. Ooh, such a glare. -3 times 4 squared plus 24 times 4 minus 45. 3. My vertex is at 4, 3. Okay. 1, 2, 3. So there's my vertex. So now I know it's going to be up, or is it going to be down? Well, if it's negative on the x squared, I know it's going to be down. That's something we know right away. And if I asked you things like, what's the y-intercept? Y-intercept's all the way at -45, very far down here. So we could write this in a vertex form, because I would like to show you how to do it in a vertex form, and you can do that by completing the square. Let's do it in a vertex form. In the vertex form, I better have a 4 and a 3 somewhere in my vertex form equation. So let me show you one more time how to do this. I take this equation and I write it like this. I write y equals -3x squared plus 24x minus 45. Okay? And I'll go through the steps, hopefully a little slowly, not too slow, but you'll make sense. You take the number and bring it over with the y and change its sign. So now you have y plus 45 equals -3x squared plus 24x. Now you see how this has a -3 in front? We want it to just be a 1, so we need to factor that out. So we're going to factor out a -3 from these two right here. And we're going to call it x squared. -3 from 24x would be -8x, and then put plus blank. And we're going to fill in that blank in a minute. On this side, we're going to have y plus 45 plus blank. Okay, so I brought my 45 over. I factored out my -3. And now what do I put in the blank? Well, I half the middle, square it. Which one's my middle? This guy. Half that middle. Half of -8 is -4. Square it, 16. Do I put a 16 over here? No. Wait, what? Why not? Because you factored out a -3. So you have to accommodate for that. So what does that mean you really had originally? Well, that means, what is -3 times 16? It's -48. That's what goes on this side. Where did I get the 16? I half -8. Half of -8 is -4. Squared is 16. You don't want to write 16 over here unless this was a 1, unless there was nothing in front. You could put a 16 here. But because you factored out a -3, you have to, accommodate for it, which means that this side was -48. Now, let's clean this side up. Let's clean the left up. +45, -48 makes a y minus 3. -3 stays there. This right here is a trinomial that if you were to factor it, which you know how to factor, would become x minus 4 squared. Where did I get that -4? Hint, 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 it's what you took a half of. And then put a little squared there. If you FOIL this out, x minus 4 times x minus 4, you would get x squared minus 8x plus 60. Now, all you have to do is add the 3 back over. Set it equal to y. X minus 4 squared, and now add the 3. This is the vertex form. Let me see my vertex. Change that sign. It would be vertex 4. Keep that sign 3. 4, 3. Axis of symmetry, x equals 4. Now, a couple other quick questions they may ask you. We'll go back to the graph on this one. What if they ask you something like, what's the domain? As you know, we will never stop doing domain. How wide is this picture getting? Well, remember, even a parabola, even though it looks like it's going straight down, if I were to continue to stretch this on and on and on forever and ever, my domain for all parabolas, it's always, always, always negative infinity to infinity. Always. Always for parabolas. What's the range? How tall is this thing getting? What's its lowest point to its highest point? Its lowest point on the y-axis, since this is going on forever and ever, its lowest point would be negative infinity. And then it would go all the way up to this point on the y. This is 3. And you put a bracket there because you're closed at that point. Some other things they might ask you. On the open interval, where is it increasing? On the open interval means you don't have to do brackets. You just always use parentheses. So you read the graph, remember, from the left to the right. What's my pen doing right now? It's going up. It's going up along the x-axis from negative infinity until where on the x-axis? Until 4. So it's increasing from negative infinity to 4. Make a little note on x-axis. You always are looking at the x-axis for increasing and for decreasing. From here, it starts to decrease. Starts to decrease. So it's decreasing from 4 to positive infinity. These both are on the x-axis. Okay? You could be asked questions like this. So that's all about vertex forms of quadratics. Now, let's do some easier stuff. Max and mins, also known as extreme values. Sometimes they're called extrema. So if you have a parabola that looks like this, that point right there is known as the minimum. It's the lowest point on the graph. If your parabola, though, looks like this, then that point at the top is your maximum. It is the highest point on the graph. Those 2 points are the vertex of the parabola. Both of them. They're both the vertex. So to have a maximum or a minimum, it occurs at the vertex. At the HK. More specifically, it's at the K. It's at the Y value. Your max or your min occurs at that, whatever the Y happens to be. It's all the way up here, or it's all the way down here. The X tells you the position. The Y tells you where it's actually located. So to find a max or min, you could do a couple things. Again, there's just so many things to do. You can complete the square. Put it in vertex formula because the vertex is the max or min. And then you can graph and choose the Y value of the min or max. Don't pick the X, pick the Y. And they're going to do that because, you know, they're multiple choice. So they're going to try to trick you. So let's do this one. Let's find the max or min value for P of X equals 2x squared plus 4x minus 16. So find the max or min value. And we're going to do this on Desmos because I've been trying to use Desmos a little bit more. I love my graphing calculator, and we'll do it in a minute, but with another problem I have. I kind of want to show you on Desmos how to do this. So we're going to find the max min value for 2x squared plus 4x minus 6. So all you have to do is type in desmos.com, and then it asks you to click on a calculator, the graphing calculator at the top. And right here in this first line box, I am going to type the function 2x squared. So 2x squared plus 4x and minus 16. And you can zoom out and zoom in. You can move this right now. Right there, is that the lowest point on the graph or the highest point on the graph? And if you click on it, it actually gives it to you. I don't know if you can see it. It's very light. It actually says that point is -1, -18. -1, -18. So is that the highest point or the lowest point? That's the lowest point on the graph. That's a minimum. Which one would I choose as my minimum, the -1 or the -18? Well, you would choose the Y value, the -18. This is much more easy on Desmos, I will say that, than TI-84. And I love my TI-84, but like it just being right there is awesome for me. -1, -18. So let's put that in our notes just so you can see. So it was all the way down here, right there. That point is a minimum at -1, -18. However, the minimum value, that's what they'll ask you, you would choose -18. Okay. If you do this on the TI-83, you have to do second calc minimum, and it's not hard, but it's just, that was much easier on Desmos. It kind of gives it to you. All right, now, because I'm a person of torture and I love to torture you, let's put this in vertex form because we need to make sure we're doing this correctly. I know you don't like it. My students hate completing the square too. It's a common thing, but we're going to put this in vertex form. We're going to do it. We've got this, okay? Y equals 2x squared plus 4x minus 16. Take that minus 16, bring him over to that side and change his sign. Y plus 16 equals 2x squared plus 4x. This has to be a 1, so I'm going to factor out a 2. X squared plus 2x plus blank. Y plus 16 plus blank. I mean, when you do enough of these, when you do practice, it gets to be so second nature to you. Half the middle. Half of 2 is 1. 1 squared is still 1. But you do not put 1 over here. No, no, no. You put what the factored form was before I took out a 2. 2 times 1 is 2. Well, look at there. Now I have y plus 18. What do I have on this side? Well, the 2 stays there. I write it in a factored form. Oops, I was a little squished there. That factored form is always x and then whatever that number is, plus 1 squared. And then bring the 18 back over. You would get y equals 2 times x plus 1 squared minus 18. Look at the vertex. Change that sign, -1. Keep that sign, -18. And that's your minimum value in that sense. Easy peasy. All right. One more little interesting problem that they'll give you tonight. This one's probably, I'd say this one's the hardest one. Again, everything else you could probably read off of a graph. It says, find an equation of a quadratic function with a vertex at 2, -3. So they're giving me the vertex, but it's passing through the point 869. Find an equation of a quadratic function with a vertex of 2, -3 passing through the point 869. Oof. So here's what you do. Since they gave us a vertex, I'm going to use the vertex formula. Vertex formula, remember, is, sorry for all the shaking, my dog is under the table, like pushing it. Y equals a times x minus h squared, whoops, plus k. Okay, there's your vertex form. So we have a little problem here. We know the vertex. We know the h. H, put a 2 there. We know the k, put a -3 right there. But we don't know that a. So we actually have to figure it out. So how do we figure it out? Well, they gave us a point. If they give you a point, that means this is your h, this is your k, this is your x, this is a y on the parabola. So those numbers I put in here and I solve for a. So it's not as hard as actually it looks. My y is 69. The a, I don't know. We're going to figure it out. The x is 8 minus the h is 2 squared. The k plus k would be -3. And then you clean it up. Do your parentheses first. 8 minus 2 is 6. 6 squared is 36. So I'm not going to write a 36. I'm going to write 36a minus 3. Then I'm going to add 3 over. So I get 72 equals 36a. And then divide by 36. A is 2. Now that's not what the question asked for. It didn't say, tell me what a is. It said, find an equation of a quadratic function. So what this means is, if I now replace my a, keep my y, replace my a with the a that I just found, which was 2, keep the x, replace your h, and replace your k, that would be the correct vertex form. If the question tonight for homework said, write the equation in vertex form, this would be it. The a would be the 2. And that would be the part really that was missing. If, however, it said write it in standard form, and I did this on purpose, I just said find an equation. If it said write it in standard form, you have to do some extra stuff. You have to go like this. Y equals, you actually have to FOIL it all out. Remember, standard form is ax squared plus bx plus c. You have to FOIL this out. It's not too hard. It'd be 2 times x minus 2 times another x minus 2 minus 3. And you got to do the FOIL part first. FOIL. First, outside, inside, last. So this would be x squared minus 2x minus another 2x is minus 4x. Negative 2 and negative 2 make plus 4. Don't forget you got that 2 on the outside. So you got to distribute him in. So this would be 2x squared minus 8x plus 8 minus 3. And then combine the two numbers here. Jack. Y equals 2x squared minus 8x plus 5. That is standard form. That is vertex form. That is standard form. This is going to be, like I said, probably the hardest one. When you get a question like this, find an equation of a quadratic function with a vertex here passing through a point. You got to use the vertex form, find your A, plug it back in, and then let's say they said find the equation in standard. You'd have to go all the way down to here. Okay? Now we're going to do a little calculator. We're going to model a quadratic, modeling a quadratic regression. This is really easy. And this one I don't know how to do on Desmos yet, but I'll probably figure it out. I probably could just easily Google it, but I haven't. I'm much more familiar with my little TI calculator here. But they're going to give you, well, first of all, we're making scatter plots. Remember, you could make a scatter plot like this. You could have a scatter plot go like this. Okay. If it's pretty straight, we usually do a line right through it. And it's a linear regression. That's what we say, linear regression. However, if it kind of starts to curve and it looks like it could be in a parabola shape, it might be a quadratic regression. So let me give you an example here. This is time in X and percent in Y. And they said this is, move my thing here. My dog was messing up everything here. This is the mobile consumption. Whoops, throughout the day. I mean, you don't have to write this, but that's really what it is, where X equals 0 is noontime. So they're going to give you a chart here, an X chart. So 0, which is noon. 5 hours later is 5 o'clock. 8 hours later is 8 o'clock. 11 hours later is 11 o'clock at night. And this is the percent of mobile consumption. 5.3, 0.9, 2.6, and a 5.6. Okay. So we are going to model a quadratic regression. Okay, so what you do, move my calculator right there. Okay, you're going to hit on the second line right here on the second line, it says stat. You're going to hit stat, and I'll write all these notes down. And you're going to see edit, hit enter. And I have things in my L1 and I have things in my L2. So to clear them out, you go up to L2, clear, enter. Go over to L1, clear, enter. And we're going to input into L1 our X's. So 0, 5, 8, 11. I'll just type 44. And in L2, I'm going to put my Y's. 5.3, 0.9, 2.6, and 5.6. Okay? So let me write that step real quick. You go to stat, edit, and input your L1 and L2. Make your L1 your X, your L2 your Y. Okay. Once you've done that, we're going to plot these points. And the way that you do that is you hit the second button, which is right here, if you can see my finger. Second Y equals. And it should say stat plots. We need to turn on that first plot. So we're going to hit enter, and right now it should say it's flashing on. So I want it to turn on. So I'm going to click enter. The type, I want the first type with all the scattered dots. So second thing you want to do is you want to go to second Y equals, turn on your plot. And then to graph it, you hit zoom 9. Now, looks like there's a random dot up here. Hopefully I typed in the correct one. Let me check my stat again. 0, 5, 8, 11, 5.3, 0.9, 2.6, 5.6, yeah. Okay, so kind of looks like it's curving a little bit, if you can notice it. Okay, and it asked us to model a quadratic anyway, so we're going to do the quadratic regression right now. So the way that you do that is we're going to go back to the home screen, second quit, go back home. And again, I'll show you what I'm typing. I'll write it out for you in a minute. You're going to go back to stat, over to calc, and then scroll down till you see, I think I missed it, quadratic. Where's my quadratic? There it is. I missed it. Number 5, quadratic. So hit enter. It's going to ask you a couple questions. Whoops. X list, Y list. Just hit enter. L1, L1, enter, enter, and calculate. Okay, so let me write that down. Hit stat, calc, quadratic regression. And look at what comes up for you. It actually even gives you the standard form of the quadratic. So you are going to put this A value in for A. You're going to put this B value in for B. And then you're going to put this C value in for C. And so you're going to write, and I can't remember if they make you do 2 decimals or not. I would say do 2 decimals. So for A, I'm going to write 0.14, Y equals 0.14 X squared. B, negative 1.51, 1.51X. And then C, 5.24. Supposed to be a 1.51. And that is the quadratic regression model of this right here. All right. One more thing, and then I'm done with this lesson. I just want to do one more thing and get out of the way. Then we'll take a break, and I will just start on 3.3, but we will not finish it. We won't go that long, I promise. But I want to get this lesson out of the way. I know it was a big one. I even wrote myself a little note. I was like, this is a long lesson, but we're just going to get done, and I'll give you a break in 1 minute. I know we're all hungry. My dog is going crazy. Height of an object. Our last thing, and the last thing you'll see on homework. Height of an object can be written in a quadratic equation also. And the formula for height of an object, S of t, equals negative 16t squared plus v sub 0 of t plus s sub 0. And let me explain what these mean so you don't kind of get overwhelmed. So t is time, usually in seconds. This is your gravitational force. Gravitational force. And this is in feet per second. If we were doing meters, we would have to change that gravitational force. We'd have to change it to meters. This v sub 0 is your initial velocity. And this s sub 0 is your initial height, the initial height of the object, the ball that you're throwing, or whatever. So t for time, v sub 0 is initial velocity, and s sub 0 is initial height. And they're going to give you this in the form an equation, and they're going to ask you some questions. Don't freak out. It's not that hard. It's just a parabola. Okay? So let's do this. A ball is projected upward with an initial height. See, there's that word. So we know where this is going to plug in. Initial height of 100 feet. And an initial velocity of 80 feet per second. And there's going to be a couple of parts to this. Give the function. So write the function. That's not hard. Part B, when does the ball reach its max height? Part C, what interval will the ball be above 175 feet? And then one more question. When will it hit the ground? Okay. So a ball is projected upward with initial height of 100 and initial velocity of 80 feet per second. Let's write our function. So again, I'm looking up at this formula right here, and I'm going to write S of t equals negative 16t squared. That's not going to change. Plus my initial velocity, according to the story, is 80. So plus 80t plus my S sub 0, my initial height is, they told us, 100. So there you go. There's the function. When does the ball reach its max height? When does the ball reach its max height? Okay, so I'm going to do this on Desmos again because I was playing around with it and I was like, wow, this is not so bad on Desmos. On my graphing calculator, I would have to change the window. It's, again, you can totally do it. You would just have to change the window. So let me just switch on over here to Mr. Desmos. And let me type in negative 16x squared plus 80x plus 100. Now, you see how it's like off my grid, so I'm going to kind of want to like zoom on out a little bit, and it's definitely, ooh, look at how high my window is. My window goes all the way up here. If you click on it, and I know it's hard to see, let me zoom right back in here. If you click on that right there, it actually, hopefully you can see it. It says 2.5 200. 2.5 200. That's the max right there. So right here is the max of 2.5 200. Now let's explain what that means real quick. 2.5 is my x, or my t in this case, my time. This would be t equals 2.5 seconds. It reaches a max of 200 feet. So that was really easy to see right from that graph. Much easier than my TI-84, which I hate to say because I love my TI-84, but it was, the window was already there for me just looking at Desmos. Now let's look at the next question. What interval will the ball be above 175? So right here is 180. What you could do is actually make a line of 175. Let's see if it actually do it. Oh, it doesn't. Let's see if it'll do y equals 175. There you go. Look at that. Look at that. Y equals 175. What interval is this graph above that line? Well, and it kind of actually gives me the little points right there. And if you can see it, it says 1.25, 175. And then it says 3.75, 175. So back to my little camera here. Let's say this is the 175 line. This point right here and this point right here. This was the point 1.25, 175. This was the point 3.75, 175. And again, the question is asking, well, what interval will it be above 175? Well, from 1.25 to 3.75. From that time, from 1.25 seconds in the air to 3.75 seconds, this thing is going to be above 175 feet when I throw it up. That's kind of neat. Last but not least, let's answer this question. When is it going to hit the ground? When is it going to hit the ground? So, going back to my picture. The ground, and I'm going to get rid of this 175. The ground is down here. It actually hits the ground here. Remember, your Y value is 0, meaning it's on the ground level 0. Think about that. So it says at negative 1.036, well, negative 1.036 would be going backwards in time. You would go negative 1 second. You can't go backwards in time. This one says 6.0360. That's when the ball goes up, comes back down 6.03 seconds later. That would be when it hits the ground. So again, just drawing it for you, it kind of goes like that. So right there, at 6.036 seconds later, it's hitting a height of 0. Height in feet of 0 at 6.036 seconds. And I think you just have to round it to 6 seconds. So pretty easy to do a height of an object, a ball going in the air, and you'll have one just like it. All right. Thank you for bearing with me. I just wanted to get that done. Let's take a break, and then I will come back